Product rule is another rule which allows us to differentiate more complex functions. We'll show how product rule works just using an example. So we'll use this first example where there's two functions multiplied together. Product means multipliers. 3 times 8, you say the product of 3 and 8 is 24. Okay, so if we wanted to differentiate this first function, we could expand the brackets. We could just use our FOIL skills. 6x squared plus 14x plus 3x plus 7. We could collect some like terms. And then we can just differentiate it using our power rule. Using whichever notation, I'll use dy dx. 6x squared differentiates to 12x. And 17x differentiates to 17. Alright, so an alternate method is using this product rule. Okay, product rule states if y is two functions multiplied together, okay, and we're going to call them u and v, then we can find the y dx, that should be y dash there. Can you change that on your notes, please? Y dash is u dash v plus uv dash. Let's have a look, see how it works. So we see there's two things multiplied together. I'm going to call this u times v. Okay, where u equals 2x plus 1 and v equals 3x plus 7. Okay, why they choose u and v when the letters are so similar, I don't know. U dash is 2 and v dash is 3. So I can find the derivative. Y dash equals, once I've got this grid of 4 things, it's just about selecting the appropriate function or derivative. U dash is 2, v is 3x plus 7, and then multiply together, plus u, which is 2x plus 1, times v dash, which is 3. Looks pretty good. Is it the same as what I got by just doing FOIL expansion? Let's have a look. May as well expand this guy, 6x plus 14, and expand this guy, 6x plus 3. Collect like terms, 12x plus 17. Okay, so this is the same, they're the same, which means that my product rule works. You can look for a formal proof in some old textbook, but you're not expected to know the formal proofs, just be able to use the rules. Alright, so we'll look at a few examples where it might be a bit more useful to use the product rule rather than just doing FOIL expansion. So example 1, differentiate this function. We've got 3 terms here and 3 terms here. Sure, we could do expansion. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, the expansion gets really messy. We'll have heaps and heaps of terms. Instead, I'm going to use the product rule. Use the product rule. Y equals u times v, where u equals the first function. Some people like to put a u and a v in here just to show what they are. 5x to the power 7 plus 3x to the power 8 plus x, and v is the other one, 3x plus 8x plus 9. Okay, probably could have just collected like terms in the v function, but that's all good. So we'll just differentiate both of these. U dash is 12, not 12, I'm multiplying by the power. 35x to the power 6 plus 24x to the power 7 plus 1, and v dash is 3 plus 8. In other words, v dash is 11. I'm trying to find the derivative of the original function. I'll use my product rule. Y dash equals u dash v plus uv dash. Here the dash means du dx or dv dx. U dash is 35 x to the power 6 plus 24 x to the power 7 plus 1. Okay, I grabbed it from here. Times v, which is 3x plus 8x plus 9, plus u. U is this function, 5x to the power 7 plus 3x to the power 8 plus x, times v dash, which is 11. Okay, and then if we wanted to, we could expand all the brackets and collect like terms to simplify. Okay, so from there we can simplify. Okay, so it's always the same idea. Two things multiply together, call one u, call one v, apply product rule. In example 2, we've actually got two things divided by each other, but we're just going to, I guess, cheat a little bit. And I'm going to make this instead x plus 8 times 2x plus 7 to the power minus 1. So I'm bringing this denominator up to the top, which means I need to make its power minus 1. That's just index laws. So here's my u, and this whole thing is my v. I can use the f of x notation, that's all good. I've still got u times v, u, okay, where u equals x plus 8 and v equals this whole thing, 2x plus 7 to the power minus 1. I'll differentiate both of these in turn. U dash equals 1, and over here, ooh, that looks like a chain rule. So I might need to use some different letters. I'm trying to find dv dx. I'm going to have to differentiate this using chain rule. So I'm going to write v equals m to the power minus 1, where m equals 2x plus 7. Okay, I'm just using chain rule with different letters. I'm after dv dx, okay, or v dash. The way I'm going to find it using chain rule is dv dx and put my m in the middle. Okay, so for this, until this point, okay, keep using the proper setting out for chain rule. I'll show you in the final lesson a simplified way, but I really want you to have this chain rule idea down pat. Okay, so dv dm is the derivative of this guy, so minus m to the power minus 2. Hopefully that's routine for you by now. And dm dx is the derivative over here, which is just 2. So my v dash is going to be minus, well, m is 2x plus 7 to the power minus 2 all times 2. And I can now bring this negative power underneath again. So on the top line I'll have minus, there's a 2 on the top, and divided by 2x plus 7 squared. Right, so all that work was just to differentiate the two original functions. Now I can finally find my derivative up here. So my derivative will be this same formula, u dash v plus uv dash. Slot in all of these 4 things. So these 4 things that I've circled are the things I'm going to substitute into this formula. Might need to give myself some more space. Au dash is 1 times v, which is 2x plus 7 to the power minus 1. U is x plus 8. And v dash, well, I can use any of these different forms. I'm probably just going to use this form because it looks the same as my v, and it'll make it easy to compare the two. Alright, so times minus 2x plus 7, power minus a half times 2. We've actually got to simplify these as well. So I think the easiest way to simplify it when there's negative powers is to write them as their appropriate fractions. There's 2x plus 7 to the power minus 1. I'll bring the 2x plus 7 down and make the power positive, so positive power of 1's there. We don't need to write the 1. Okay, for the second term, on top I'll have 2. I've got the 2 here and the x plus 8. Okay, but that's all going to be negative because I'm multiplying by -1 as well. All over this guy, but with a positive power. Because we've brought it below the fraction line. Just index laws. I want to add these two together. I need a common denominator. I've got 2x plus 7 squared here and 2x plus 7. I need to have 2x plus 7 squared as my common denominator. Okay, what did I have to do to get this from 2x plus 7 squared to 2x plus 7 squared? The answer is nothing, so I'm going to do nothing on the top line. And to get 2x plus 7 to 2x plus 7 all squared, I need to multiply by 2x plus 7. So it'll go on the top line. Okay, now that I've got common denominator, I can add the two top lines. Add the two numerators. So I'll do that. A big common denominator of 2x plus 7. On the top, 2x plus 7. And I've got plus minus 2x plus 8, so plus minus 2 means minus 2 x plus 8. Expand on the top line, 2x plus 7 minus 2x minus 16 on 2x plus 7, it should be squared all the way through. And then we can just collect like terms. The 2x's cancel each other out, and we've got 7 minus 16, so minus 9 on 2x plus 7 all squared. Alright, so there's the final example as well, where there's 3 things multiplied together. Might leave that for the next lesson. So the questions that I want you to do, it says 3AE in question 4. Not sure why these letters are all wrong. This should be question 6, and you should be able to do all of those. Yeah, you should be able to do all of those without that last point. Alright, and next lesson we'll be combining all the rules together, and I guess it'll get a little bit more complicated, and your C and J will be really important. Alright, bye.